Okay, welcome back. So hopefully you've had a chance to simplify these equations and isolate for the variables. So with the second equation, I'll start with that one. I use distributive property here, expanded through the brackets to get this line right here, 3x minus 12 plus 8y plus 4 equals negative 2. Collected my like terms, brought the minus 8 over to the other side, added 8 to both sides, just simplified the equation so it became a little bit neater to work with. So I got 3x plus 8y equals 6, which is nice than what we started with. Now, even still, once this is simplified, the easiest variable to isolate for in either equation is the x value in the first equation. Okay, so that's this one right here. So I move the 6y over by subtracting it from both sides, and I have x equals negative 17 minus 6y. Okay, so maybe you got further than this already. If not, what you want to do here is, again, here comes the big substitution step. We have a variable by itself. In this case, it's x. So we replace the x in the other equation with what we know about it. So we know that's equal to negative 17 minus 6y, so that replaces the x in the other equation. Okay, so once we do that, you can see that the x gets replaced with negative 17 minus 6y, and then we can start solving the rest of the equation because now there's only one variable, in this case, y. Okay, so let's go through the algebra here. So the 3 gets distributed through this bracket here, so I get negative 51, 3 times negative 17, minus 18y, okay, plus 8y equals 6. Okay, so let's keep solving here. So negative 18y plus 8y is negative 10y. Okay, I'm going to add 51 to both sides of the equation and try and isolate. So if I add 51 to both sides, 6 plus 51 is 57. So if I divide both sides of the equation by negative 10, I get y equals negative 57 over 10. Okay, so once you have that answer, reduce it as far as you can go. This does not reduce any further. We have our y value. We still need to find our x value. So now what we should do is, now we can use an original equation to try and solve for the other variable. Okay, so between equation 1 and equation 2, obviously equation 1 is far, far easier to work with. Okay, so x plus 6y equals negative 17. Let's use that one. Okay, so substitute the y value in there. So x plus 6 times negative 57 over 10 equals negative 17. Okay, so again, just a matter of simplifying and isolating for x. Okay, so 6 times negative 57 over 10 gives you, if you run it through your calculator, minus 171 over 5. Okay, so I'm just going to add that to both sides of the equation. So I'm going to have x equals negative 17 plus 171 over 5. I know it looks ugly with the fractions, but fractions aren't that bad to deal with, right? So we run this through our calculator and we get 86 over 5. Okay, so put those together, we now have a point of intersection. X equals 86 over 5, y equals negative 57 over 10. So just to check, we'll see we get the answer up there. So that would be a point of intersection. Okay, if you want, you can take a look at the graph here. This one would be very, very hard. This would be one of those ones that you wouldn't want to necessarily solve graphically because it's not a nice point of intersection. We could just only estimate at best from a graph. But now that we have substitution, we can find the exact answers. Okay, so that's the whole idea of substitution. And again, there's a certain series of steps that you can follow every single time to get your answer. If you forget them, they're right here. Once you've gone through a bunch of them, it'll become a lot easier. So please make sure you do the homework and get lots of practice in. Okay, so the homework is there. So there's some stuff from the textbook to try, and there's a worksheet up on the website that has some more complicated type questions in there that if you were looking to challenge yourself, do something a bit harder, you can do that as well. Okay, so that's it. That's all.